Get ready to learn some physics. Push.
Cool. You got it, kids. Push and a pull or forces. Yay!
Today on the Jen Show, we learn forces.
Ow! Gravity! Ow! What the heck? An orange! Okay, now that's just silly. Grapes don't even grow on trees.
I'm going so fast. I don't move.
On Earth, there is air resistance. That is why the paper falls slower than the rock. But in space where there's no air, both paper and the rock will hit the floor at the same time. Hi. It's like fighting with yourself through a mirror.
Dude, like, what's your problem? You wanna fight? Nah, man. I don't want no fuss. I don't care, man. We're fighting. We're gonna fight. Put 'em up, put 'em up. Here I come, man. Here I come. The symbol for force is...
Ah!
The unit for force is
N.
Duh.
There are two types of forces: contact force and long-range force. Not that kind of long range, unless you're a superhero. We're talking about gravity. Normal force is why we don't fall through the ground. In this photo, it demonstrates that the Earth is putting an equal amount of force as gravity is. Hence, nothing is moving, falling, or whatever.
Here's a diagram. Let's draw an eye, some eyelashes.
Just joking. Clearly, the boxes aren't falling through the ground, so we find the force of gravity, then find normal force.
We already solved that gravity is 9.8, and the total mass is 3 plus 5. That equals 8. Plug it all in, and that's what you get, mate.
Ah, friction. Without friction, we wouldn't be able to live on this earth. We would not survive, there would be none of us. There wouldn't be this video. If there was no friction, we wouldn't be able to stop. So, friction is measured in something called mu. I don't know how they measured it, but that's how they measured. So, if we take this piece of ice and push it across this book that has a smooth surface, you can see that the ice is moving way farther because it takes more friction and more force to stop it. If you take the same piece of ice and put it on this carpet that has a rougher surface, you can tell that the ice barely moves. Friction is taking a bigger toll on this ice. Here, guys, is a spring. When you pull on both ends, it has a force to pull you back in. If you try to compress the spring, it wants to push you back out. So just like in a Jack-in-the-Box, this spring is loaded with energy until the lid is open and boom, it releases force and you get your Jack-in-the-Box. Dun, 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 dun. Dun, 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 dun. I'm gonna get you, little kids!
Take strings on a guitar. The strings are pulled tightly from one end to the other. This creates an equal force throughout the strings.
Thank you kids for coming out to open mic. Go play a little song for you. Boom, 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 boom. Boom, 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 boom. Rock on! Thrust. Just joking.
Or Newton.
Dee-ra-dee-ra, dee-ra-dee-ra, dee-ra-dee-ra.
Thank you.